I'm really excited to welcome Armin Karabassi. He's a structural engineer with a PhD in earthquake engineering and more than 10 years of industrial experience. As the leader of the construction practice group and the senior risk engineer at AXA XL, Armin supports the underwriting and claims teams globally via technical risk assessment in construction as well as the energy sectors. He will show us another use case from the insurance sector, so you see that insurance is going all out in data and AI. His talk is called Risk Engineering Co-Pilot, RAG versus Fine-Tuning in Creating a Risk Assessment Assistant Tool with Domain-Specific Knowledge for Insurance Industry.
Thank you very much, and good afternoon, ladies and gentlemen. Thank you for being here. Good afternoon. For the introduction, I'm happy to be here among all of these experts, data scientists, and as you heard, I'm more on the technical side, but a little bit far away from being data scientist. But I'm happy to present you an innovative proposal that we have at Risk Engineering at AXA about having a co-pilot for our risk assessments. Before telling you why such a tool could be beneficial for business for us, maybe I have to tell you a little bit where we sit, the risk engineers, for those of you who may not know exactly how the structure works. So underwriters are usually, if you know, the people that companies go to if they want to get a insurance policy, and they usually bring the risk engineers the submissions, technical stuff, with all the questions that they have to understand the risk. And our job, the risk engineers, is to translate the technical documents, technical stuff for the underwriters in a non-technical way so that they can understand the risk, to understand if they have to apply any kind of exclusions there, and using that recommendation to go into the pricing people and price the risk and get the policy done. This is where we come into question. But maybe a little bit then going further, my expertise being a structural engineer, I'm giving you an example. Let's say it's a construction project and you're building something in the middle of many high-rise buildings. And as my title says, I work on the liability side, so everything that does with a third party, Haftpflicht in German, and whatever damage can cause for the third parties when such a project is going on. And I would love to have a tool that actually, if I can feed it the submission documents, and that includes the geotechnical report, that includes the drawings that I have for the construction project that is going to be built, then if it can actually give me a kind of estimation risk assessment that a risk engineer is going to do. Of course, we have heard at the conference many sessions, many talks about the use of RAG, so I'm probably not going to spend that much time on details of the RAG. Most of you may know about it, have used it, but to just indicate, the first tool that came to mind here was using the RAG, and for your information, what I've been trying to use, it's the Mistral 3B base model, so trying to get it the technical documents that we have and see that if it can give better answers, technicals that a risk engineer is going to do. To just give you an idea about the result that what it was seeing, this is just based on the publicly available data. It's from Swiss Re Corso that they have about the risk for wind turbines and offshore. And I'm asking it this, that's why the typhoon is the biggest natural catastrophe risk for those. And it gets from the document that I'm giving it, it's actually finds what are the major risks, that's the wind and the water, that probably causes problem for them. To just be clear also here, there may be questions why I've concentrated and used this Mistral model. I've tested a few other models, but I'm speaking about this work that was done end of last year. Of course, if we want to know that now last month. There's a lot of new models, and every week I think new models are coming out, but kind of testing a little bit of the base models for the risk assessments that we have done. I was trying to test few others and giving them the kind of information to see that if I can trick them in seeing that how far they're going to hallucinate and giving me some information. One question, for example, I was asking the base model was about what are the risks to build a tunnel in the sky over the clouds. And I think Mistral was one of the few ones that actually got it and was telling me, oh, that's a very nice joke. But if you want to like put it as a humor, then this could be the things. But I think I remember maybe it was it was GPT 3.5 that was getting the question very serious and hallucinating some risks that actually does not exist. There's a risk that the tunnel may fall off over the clouds and on going on. So just back to this, that's why I'm trying this, but of course one thing that can be considered also in the future is to try other models as well, which is a legitimate question. I'm just making a comparison with the newly model of the GPT-4o of OpenAI. And I think the model, even the base model, is getting it quite good about this risk because it gets still the kind of information that we got from RAG, from the previous model that you saw. Although one problem that I see here, it's a little bit wordy always the answers from the model. Of course, there are ways that we can just limit the answer, but in my experience, it's not always successful to rail guard the model to make it answer exactly the way we want. Going to the next level is to use the fine-tuning. Maybe by show of hands, I would love to know how many of you have actually fine-tuned a model, just to get an idea about, yeah, that's great. Probably that's a good thing, a good mix, and I would love to hear also from your experiences maybe during the Q&A questions and also after the presentation. But for those of you who may not or may be less familiar with the fine-tuning, it's more about updating the base models for specific tasks. And I have to stress that because one cannot fine-tune a model to do everything, but actually we just try to fine-tune, let's say in this case, to fine-tune it for risk assessments in the construction, for liability, for these kind of tasks. So I cannot fine-tune a model that is going to do everything for AXA XL, but actually I have to be very specific about the tasks that I'm fine-tuning my model. And this fine-tuning is actually getting a lot of attention because of all these small models are coming out, which makes them easier for fine-tuning, and they cost less, but they don't perform very well, but it's shown that fine-tuning can make them actually give good results. I will give you, I think, 2 examples here of those smaller models. I think one is about these tiny stories. It's a data set of short stories that has been generated by GPT 3.5 and 4. It's kind of stories that you're going to tell typical 3-4-year-old kids, and using those or applying them on smaller models that actually do not give very good coherent texts, you can get them to actually write or produce very good texts with perfect grammar. You have the reference here in case that you're interested in knowing more about this study. I think the other one is about the Phi 1, the small version that actually was also fine-tuned, and for this one it now produces very good coding exercises based on the data set that was trained on. So it was just showing what kind of achievements can be done fine-tuning these smaller models. Of course, there are obstacles. It's not that it's very easy, and it's always the question how we can deal with storing the weights of the model once it's fine-tuned. We're seeing that nowadays the language models are getting bigger, of course, because they have better performance, the bigger ones, getting bigger and bigger, and that brings us more parameters, and how to deal with them, it's a huge challenge. One possible solution in this case is to leverage from the fine-tuning the best part of those, like specific part of the models, without having to touch all the parameters that we have. So it's kind of like a lightweight fine-tuning of the model. And for that, there are three methods that I'm going to talk about, mention, but the one that we have used for this work, it's the LoRa. And for those of you that who have not familiar with this method, it's more about fine-tuning part of the parameters that you have without having to work on the whole weight matrices that you have. And then having those fine-tuned parts, you can use it kind of like a plug in, plug out for your LLM model for specific tasks. So if you're doing task 1, you can use this kind of fine-tuned part for fine-tune this part, and then you don't have to worry about the original weight that you have. I'm going to explain a little bit about what is the concept and how it works. Assume that the base model has this weight matrices of W0 here, and it's a dimension of D by K. And our goal is actually to produce or actually get that delta W to make it better on its specific task. Instead of actually working on that delta W, we can decompose, for those of you who remember that from your math classes from high school or maybe from the graduate studies, you can write it as a B by A, but the B and A actually are going to have much smaller dimensions, which they're connected with the rank, which is the R, which is way smaller than the minimum of D and K. Maybe next slide shows this better a little bit. So that delta W that has a dimension of N by N matrix is that. And once you decompose that with having that rank R, which in this case, example is if we use R as 4, then you're going to have two matrices, N by R and R by N. And the numbers that actually you're seeing here, it shows you the difference of the memory that it's required you if you had to work on the delta W itself rather than working on the B and A and decomposing it with smaller matrices here. And with this example, with a rank of 4, you have actually a matrix which is about 512 times smaller. Going back to a little bit of uses that you will going to find in the LoRa's paper, that the reference is also in the slides. The first one is actually on the GPT-3. You're going to see with a rank of 4, so that R is picked with a 4. So if we only fine-tune the query and the value projection matrices, the checkpoint size, that's actually the file that you're going to have the weights information that you're going to have to use. That's reduced roughly by 10,000 times. So instead of 350 gigabytes, we are talking about 35 megabytes. Of course, you always have to still keep that huge 350 gigabytes, but imagine that you have fine-tuned it for 10 tasks or 100 tasks. You don't have to store 100 times of 350 gigabytes, but actually you're going to have only 100 times of 35 megabytes, which is a huge difference in the memory that you're going to need. And as I was mentioning earlier, switching between those tasks are very easy, so you can just actually plug in, plug out the delta W that you saw. And even if you are fine-tuned it for a specific database and you still want to update it, you don't have to do the whole thing from the beginning, but actually you can start from where you left off with your delta W. So you don't have to do everything from scratch. Of course, we don't have to do everything in the code. There is a library for that. You see the documentation from the Hugging Face, and there is some parameters that you actually have to work on. And probably one thing that it's the most important, it affects the work, the time, the size of work that you're going to do. It's the R, picking of R. In the work that we have done, I've worked with R64, but of course it's a very good question to ask what is going to be the effect of R when we change it, what is on the performance. I would say I have not tested that, but this is something to definitely consider. I was talking about LoRa, but I was saying that there are, of course, other methods that exist, and one is this adapters layers that can be used again to light fine-tune the LLM, and that is actually kind of like putting some transformers block in your model, LLM model. There are also advantages of that. It's, of course, it's very fast during the training, but computing is also very efficient, but it's during the inference, it can be you can have some, introduce some noticeable latency. And the other method is the prefix tuning. That's also one method that has been used and exists in the literature. I'm not going to go that much into details of this method, but just comparing it with LoRa, it's kind of like there is not clear where to put these prefixes for the transformers that we have. Maybe I can show you a little bit of comparison between these methods. And as you see, the pink, if I'm right with the colors at the top, you see that with the trainable parameters that we have, it's kind of like LoRa is showing a constant performance up there in comparison to the other two methods that I was mentioning. The other two kind of like increase the performance, but then it decreases, kind of like it's a heel shape. For the training of this work, what I have done, it's producing questions and answers based on the publicly available data. What I'm insisting and repeating this, because this is kind of like the work that I'm doing at the moment on the Google Colab, so it's kind of like a public thing. I'm not allowed still to use the company's data there. This is something that it's going to come in the next steps. So having access to a GPU type A100 and producing these questions and answers that is going to be used for the fine-tuning, the LoRa fine-tuning from the text. So you're going to have a questions, if you have a deep excavation in this kind of soil, what could be the risk for the neighbor building? And then you're going to have the answer. You're going to have a lot of these kind of questions, and you're going to feed it to the model, and then you're going to expect that the model is going to learn from all these Q&A answers. To just come to a little bit of the initial results that we have seen, at least for me, it's the RAG. It's more beneficial for the moments when it comes to my own usage of the submission data. So it's kind of like when I have a lot of submission documents, geotechnical reports, drawing stuff, that I want to know where I have to search for certain type of information that helps me with my risk assessment, then RAG is very useful, so I have the information in the context that I need. But then on the other hand, fine-tuning, I find it's better when it comes to having an LLM with newer information, learning, or data, or domain-specific knowledge that the LLM is going to learn. And talking about that, following up for this work, of course, it's to increase the training size. For the moment, we're talking about 5,000 Q&A answers, questions and answers, but the more we have, the better its performance of the fine-tuned model is going to be. And also, once we can get over all these internal compliance and the regulation approvals, it's to feed it with all the emails, reports, internal documents that risk engineers have done over the years, doing the risk assessments, and then having a better model fine-tuned with internal documentations. And with that, I believe I'm at the end of my talk, and I would be happy to answer any questions. Thank you.
Thank you very much, Armin. I'm very happy to have the business guy being the first one that dares to put formulas up there. I absolutely love it. And I finally understand LoRa a lot better than ever before. True. So, where are the questions?
First of all, thank you for the interesting talk. My question is, did you look into agent or multi-agent based RAG workflows instead of just naive RAG? And if so, what were your experiences? Is this the next big thing after naive RAG, or do you think it's not ready?
Very good question. Short answer, no. I have not looked into any kind of like other methods than the naive RAG, but it's definitely worth checking that, I believe. And again, I'm saying, I think I wouldn't, at the end, at least my feeling is that I wouldn't come to a conclusion, or it's not the conclusion to say RAG is better, I'm going to throw out the fine-tuning, or fine-tuning is better, I'm going to throw out the RAG. But I think a combination of both methods, it's the answer to the questions. But that's also a very good suggestion to look into.
Hi, my question is, do you have any models in production for which have been fine-tuned using LoRa? I ask this because if you fine-tune using LoRa and other techniques, you quantize the bits and you lose the information. And model, even though you fine-tune it, it just is not as good for other general-purpose tasks.
Just to be sure that I understand the question, so you mean if, the first part of your question is that no, there is nothing in production that is actually in use by the OxyXL for the fine-tune by LoRa. But then to the second part of your question, what are you mentioning, to understand if I get your question correct, you mean losing what is in the base model kind of, or are you mean that when we have these, for task one, we have our weights, the fine-tuned weights, and we want to do for task two? Which
so
one?
you can either fine-tune without quantizing the bits, right? Mm-hmm. Complete fine-tuning. Or you could fine-tune using LoRa, QLoRa.
Exactly.
So both have its advantages and disadvantages.
Definitely.
Using LoRa, you have some information loss as well. So isn't that a factor for you, like losing that amount of accuracy, or?
It will. I mean, at the end, it's going to be like how would be the performance of the LLM in this domain-specific task that I wanted to do. So it's kind of like a risk assessment. But I also have to add to this that the aim is not to have a machine that is just going to be released for use for underwriters to use it. But it's still, this is my belief, that my opinion, that these machines, they still need the supervision of an expert. So it's kind of like, it would release a little bit of my work, because it's kind of like when it comes to regular risks that I have to provide to the underwriters, kind of like repeating the typical risk, it's going to help me in that way. But of course, if it goes to very specific niche risks projects, I still really needs the supervision of the human beings. That's one thing.
Any other questions? No more questions. People seem to get tired. I, of course, have a question.
Sure.
So you said you're not really a data scientist, right? Mm-hmm. Now, with whom do you collaborate to do experiments like this and get all the knowledge?
Good question. Of course, we have a team of data scientists within OxyXL, and we work on different projects. So to give everyone a little bit of also a history on this, it's kind of like this idea from risk consulting was discussed also with the data scientists. And we have a lineup of a lot of projects that they have from HR, they have that from different departments at OxyXL. And we also express our idea about what we want to do, and then say, okay, perfect, that's good. We're going to put it in line, and we're going to wait for it and see when it comes up. Of course, for me, because I believe in using data in my daily life, it's not something that I do daily, but I try to push it there. So that's the reason that I said, okay, until I get to that step that data scientists of the company are going to be helping me with doing all these things, at least when I go to them with a prototype and say, okay, this is something that I've worked on, this is what I want, this is the data that probably I'm going to use. It's better than just a proposal on a piece of paper that actually it's very unknown there. So I can give them, this is one thing that I want, and then we can work on it further. So the follow-up that I was mentioning there, it's kind of like in this line, that I have this now. We had a Gen AI summit at AXA 2 weeks ago, I think, and I was discussing also with our data scientists about the project, and I think it received a very good feedback there, and it's kind of like, it's better to go to them and have them show them this, so now they know what I'm talking about, and this is something. But then, of course, I had to also learn a lot about this LoRa myself, apply it. It took me kind of like a lot of my free time in the evening, instead of watching a movie, kind of you watching YouTube videos to learn about the method.
Absolutely love it. Thank you. That's push from data science to pull from business next level. Absolutely great. Thank you very much, Armin, for this great talk.
Thank you.